Hello everyone, welcome to the TechnoGate. So today I am going to start the subject algorithms here. So we will start from the basics. Okay. So first of all, what is the definition here? So what is the definition here? It is a combination of sequence of finite step to solve a problem. So first word here is a finite. So for a particular program, algorithm exists in a finite manner. Infinite algorithm for a particular program never exists. So your algorithm must be finite here, and here sequence matter here. So sequence of finite steps matter here. So suppose that we will take a program or we will take a problem here, how to write algorithm. Suppose that we want to add two numbers. Okay. Add two numbers. So how to write the algorithm for the add two numbers here? So sequence matters here. So make a function, make a algorithm ATN means add two number. Okay. Then what is the algorithm? So first of all, what is the first step here? So first of all, take two numbers. Okay. First step here, take two numbers. Second step is after taking two numbers like a comma b here, add a plus b and store the result in the third variable like that c equals to sum a comma b, and after that third one is return c. So c will give the output of this program. So here finite number of steps, there are three steps only, and sequence matters here. Suppose that first of write, if we write c like return c at the first step, so here return c, then after that take two number, then c equals to sum a comma b. So it does not any meaning for this. Okay, so here sequence matters always. Okay, so algorithm have some special property how to execute that problem, how to execute that algorithm. So first of all, we will learn about the properties of the algorithm. Okay, properties of the algorithm. So it's a very important part here. So properties of algorithm here. So here first one is properties of algorithms. Okay, so what are the property we have to follow here? So first one is it should take finite time. I already discussed that every algorithm must be finished in the finite time. So first property is what here? It should take finite time or finite steps. We can say finite steps. So every algorithm must be finished in the finite number of steps. Okay, this first property, the first important property. So algorithm exists only finite program, not an infinite program. Second one is what? It should take zero or more inputs. So algorithm must be work on zero or more than zero inputs. Okay, so it should take zero or more inputs here. So if we give the input, then we desired output must be in here. So at least one output. It should give at least one output. The third property. Okay, and fourth important part is it should be deterministic and definite. What is the meaning of deterministic, or what is the meaning of deterministic, or what is the meaning of definite? So definite means here for every input we all always get same output at any point of time. Okay, so fourth one is it should be definite or deterministic. So what is the meaning of deterministic? Means for every input we always get same output at any point of time. Suppose that Input is x equals to 5, we are getting y equals to 10. Output is here. After 1 month, x equals to 5, we are getting y equals to 10. After 6 months, x equals to 5, y equals to 10. So every time if we get same input and same output, we always get the deterministic approach. So for every input, we always should get the same output at every point of time. Then we can say that your algorithm is deterministic. And fifth one is, for every two steps, there must be some relation. For every two steps, there should be some relation. If relation does not exist, then algorithm may stop somewhere without producing the output here. So main thing is, between every two steps, there should be some relation. Between every two steps, there should be some relation. If relation doesn't maintain, then algorithm stops somewhere without producing any output. Okay, so that algorithm does not produce any output if you not maintain a relation between two steps. Okay, and sixth one is what? Redundancy is not allowed. Redundancy is not allowed. So what is the meaning of redundancy here? Suppose that you write x equals to 10. Okay, after that line you write x equals to x. So what is the meaning of x equals to x? No meaning. So these type of statements never exist in any particular algorithm. So these are the six basic property of the algorithm. It should take finite steps, it should take 0 or more inputs, it should give at least one output, deterministic, between every two steps there should be some relation, and redundancy is not allowed. Okay, so these are the property. So the next important thing is what here? For a particular program, we may write many types of algorithm, 1000 types of algorithm. So among 1000 type of algorithm, which one is the best? How to decide which one is the best? So for deciding a particular algorithm is best, we have to do the analysis. So next one is a very important part, is analysis. Okay, next one. So how to decide a algorithm is best among all possible algorithms? So first one is analysis. So very important part of the algorithm is analysis. So we have to do the analysis with the two terms, with respect to two terms. With two terms, first one is a time complexity, and second one is the space complexity. Time and space. So through these two analyses, we have to decide which algorithm is best, which algorithm is worst, or which algorithm is average. So here, first of all, we decide the time complexity. Time complexity. So time complexity for any program. So T means time, P means program. Any program. So first of all, suppose that you have to write a program. After that, writing a program, you have to compile that program. So compile that program. After that, run that program. So this is a compile time. And this one is the run time. So for the compile time, compiler is responsible. Compiler is responsible. And for the runtime, CPU is responsible. Central Processing Unit. Okay. And compiler is what? Is a software. Compiler is a software and CPU is the hardware. So software depends on the programming languages, Java, C, C++. So software depends on the programming languages. So in many programming languages, we can write a software here. Programming language. So time complexity, first of all, compile the program, run the program. So software including many programming languages, but runtime includes hardware here. So time complexity depends on the runtime, not on the compile time. For particular hardware, for particular CPU, how much time it will take to run n inputs, n square inputs, exponential inputs, or many type of inputs here. So time complexity always depend on the runtime, means CPU means hardware. So always remember time complexity depend on the hardware, not on the software. Okay. So how much time it will take a particular software or particular hardware to run a particular program here. So time complexity always depends on the hardware, not on the software. Clear? So here is the time complexity. Okay. So here there are two type of analysis, a posteriori analysis and a priori analysis here. So analysis are the two types here. A posteriori analysis and a priori analysis. So a posteriori analysis is depending on the hardware, depending on the processor and programming languages. So it is a dependent analysis. So a posteriori analysis is a dependent analysis, not an independent analysis. So it depends on processor plus programming languages. Okay, so it depends on the processor and programming languages, but a priori analysis is independent of the processor and independent of the programming languages. You can use any programming language and you can use any CPU. So it is independent of processor and programming languages. It is independent of processor and programming languages here. Okay. So here it is a dependent analysis. So different answers may get. Like suppose that you are using like Motorola power processor here. So suppose that output is 10. Suppose that you are using PowerPC processor, output is 15. You suppose that you are using ARM processor, output is 20. So different answers are possible in the a posteriori analysis. Here different answers are possible. Different answers are possible. Yeah. But here only one answer is possible because independent analysis here. Only one answer is possible. Okay. And third one is here the answer you are getting here, there are the exact answer. How much time it will take? Suppose that like for n equals to 3 here, you are getting like 8.75 is a exact answer. How much time, how much exact time it will get? Okay. So here exact answer, we are getting here exact answers. But here, so in a priori analysis, we are getting approximated analysis. Approximated answer. So approximated means, so total algorithm depends on the approximate data analysis, not in the exact analysis. So what is the meaning of approximated here? So suppose that n is 3, input 3, it will take like a 8.25 time, 2 seconds. Like n is 4 here, you are taking like 13.65. N equals to 5 here is taking 27.55. So approximated how much it take n square time. How much it is? N square time. n is 3 approximated to 9, 4 approximated to 16, 5 approximated to 25. So it will take approximated how much n square time, not exact answer. Okay, so always we have to do the approximated analysis, not exact analysis. So total algorithm depends on the approximated analysis, not on the exact analysis here. So suppose that I want to go from Jaipur to Delhi. So there is no fixed time in which time, in how much time we will go to the Delhi. So suppose some will like I approximated 5 to 6 hours. Okay, so this is approximated analysis. So in the real world we are living on the approximation, not on exact. How many years I should alive? Don't know. Okay, so is a approximated answer. Okay, so total algorithm depends on the approximated analysis, not on the exact analysis. So always we use a priori algorithm. Okay, so next one is how to decide the time complexity of the program. Okay, how to decide, how to get the time complexity, how much time it will take, an order of linear time or n square time, cubic time, exponential time. So we will discuss through the programs, through the examples, how to decide the time complexity here. So there are two type of analysis, a posteriori, a priori, and we are using approximated analysis. So in the next upcoming lecture we will discuss how to decide the time, how do we get the time. Okay, so next one is the how to get the time. Okay, thank you everyone.